First and foremost, I'm going to explain to you about the background of the study. Let's understand what is a PLC. PLC is a programmable logic controller. It's essentially the core controller used in the industrial automation system. It is a microprocessor-based device programmed to monitor and control process in a plant. So originally, PLCs were designed for a simple binary or logical task, but over time they have evolved and are now capable of managing complex control functions. Next, looking at the capabilities of PLC, they process input from simple switches and convert that into diverse output actions. So this enhances efficiency, ensures safety, and also help maintain operational consistency in industrial system. So however, to make sure this possible, this system must effectively program to meet specific industrial objective. Now, bringing this into the context of our project, we apply the PLC system to automate several keys in step in food production, which include sealing, quality control, labeling, and packaging. So the system also performs specific tasks such as detecting and rejecting substandard items, sorting the fruits by flavor, and also ensure the high product standards. So all of this is to contribute to a seamless and efficient workflow in the production line. There are three main issues we identify in the current food production process. First is the issue of inefficient quality control procedure. So the existing process lacks on automated quality control system. This makes it difficult to detect and remove substandard items. So in some cases, contaminants like metals can be found in the food, which raise serious health concerns and impact overall product reliability. Second is the manual packaging complexity and errors. Currently, the packaging process is done manually, especially when sorting by different flavor. So this manual approach is prone to human error, which can lead to mispackaging, waste materials, and increased production costs. It also affects the customer satisfaction due to inconsistency in the final product. So third is the problem of limited operational streamlining. So there is a lack of automation, especially with the underutilized PLC system. So this causes bottlenecks and error in the production line, which reduce the efficiency and slow down the entire workflow. So overall, this problem highlight the need for more reliable and automated system to improve quality, reduce errors, and also optimize the production process. For this project, we have outlined several key objectives focused on improving food production process using automation. Firstly, our goal is to implement PLC automation to control multiple stages of the production line, including sealing, quality control, labeling, and sorting. So this will reduce human error and improve efficiency. Secondly, we aim to integrate PLC technology into the packaging process, allowing the system to identify and sort food based on distinct flavor, which will be categorized using different package color. And third, we strive to enhance the overall operational efficiency and safety, ensuring consistent quality across all output. To break this down even further, this project falls under the scope of food manufacturing. PLC are used to automate the sealing process to ensure the freshness, and also the quality control is handled to metal detector that identify any contamination. So labeling is automated for traceability and product identification. Finally, PLC assists in sorting the package by color, which is blue, red, and green, based on the flavor.
Good morning, everyone. So today I will talk about food packaging, quality control, and sorting systems in food production. These processes help keep food safe, meet regulations, and make production more efficient. So let's start with food packaging first. Okay, so why is packaging food so important? So basically, packaging is important because it protects food, plants, and medicines from damage and spoiling. Robertson 2013 says that packaging stops food from being exposed to air, moisture, and dirt. Without good packaging, food can go bad quickly and become unsafe to eat. Most food packaging is made of plastic. Marsh and Bogusu 2007 explained that plastic is popular because it is light, cheap, and strong against chemicals. These qualities make plastic a good choice for keeping food fresh. But plastic waste is a big problem, so people are now looking for better options like biodegradable materials. In advanced technologies in packaging, scientists are working on better packaging methods. For example, Gupta et al. 2024 say that adding nanomaterials like silver and titanium dioxide to packaging helps kill bacteria and keep food fresh. Another method is vacuum sealing, which removes air from package. Zhu and Chen 2022 say this helps stop bacteria from growing and makes food last longer. For process of vacuum sealing is simple but very useful. First, food is placed into a plastic packet. Then, a machine removes the air and uses heat to seal the package. And finally, the sealed food stays fresh for a longer time. Zhang et al. 2024, Siddiqui et al. 2024. So, for this method is used for many foods such as meat, cheese, and dry food. Okay, now let's talk about quality control. Quality control makes sure food is safe and follows government rules. Early 2012 says this is important because bad food can harm people's health and damage a company's reputation. In traditional methods of quality control, in the past, food was checked using physical inspection, chemical tests, and microbiological tests. Dora et al. 2013 explained that these methods help find contamination and check food quality. But these methods take time and can lead to mistakes. For automation in quality control, technology has improved quality control. Zhong et al. 2024 explained that AI and cameras can now check food for defects. These machines quickly scan food and find problems like contamination or damage. Rahim et al. 2013 also mentioned that metal detectors are used to find and remove harmful objects from food. These automated systems make the process faster and reduce mistakes. And the last one is food sorting system. The importance of food sorting system. Sorting food is an important part of food production. Yadav et al. 2019 say sorting helps organize food by size, weight, shape, and color. This makes sure food is packed properly and looks good for customers. However, sorting food by hand is slow and tiring. Balogh et al. 2006 explained that manual sorting takes a lot of time and people can make mistakes when they get tired. So, to solve this problem, companies use machines to sort food. Vandana et al. 2021 say photoelectric sensors help machines detect food colors, which is useful for sorting fruits and grains. Thirumurugan 2018 mentions that pneumatic pushers help move food into the right category. Fatahillah et al. 2020 also explained that PLC-based sorting systems make the process more accurate and efficient. So, to summarize, food packaging, quality control, and sorting system are very important in food industry. Packaging keeps food fresh, quality control ensures food safety, and sorting helps organize food properly. With new technology, these processes are becoming faster and more accurate. Thank you for listening.
3.1 Process Flowchart. First, let's start by looking at the process from the beginning. First is sealing. The conveyor belt move the package forward, which is where the process begins. We check if the packet has already been sealed. If not, we move on to the next step. The system use a proximity sensor to confirm if the packet arrived correctly under the sealing clamp. If not, the process halts and the conveyor belt stops. Once the package is in place, the sealing clamp begins sealing the packet. Meanwhile, the system checks if the packet contains any metal using a sensor. If metal is detected, the package is rejected and a pneumatic pusher pushes it out of the system. If the packet is free of metal, it proceeds to a quality check. After a timer is activated for 2 seconds, a pass level is stamped on the package. Now, the package proceeds to the sorting stage where we classify the package by color. The system sorts cat food packets into one of three different colored package: blue, red, or another color. The blue pneumatic pusher is activated for blue colored package and the red pneumatic pusher activated for red colored package. A timer of 1 second is activated for blue package and 2 seconds for red package. Finally, if the sealing clamp confirms the packet has been sealed properly, it moves on to the next part of the process. If there is no problem detected, the sealing clamp unclamp and end the process. If there's an issue, it rejected and handled accordingly. 3.2 Required components and sensor. Now, let me explain the main components and sensors used in the cat food package sealing system. First is push button. This is the basic control for starting and stopping the whole system. It ensures that the operator can run the machine only when it's safe and also stop it at any time when needed. Second, capacitive proximity sensor. This sensor detects when a cat food packet arrives under the sealing clamp. It works by sensing changes in an electric field when the packet is nearby. It also helps to check whether the clamp is in a clamping or unclamping position. Third, conveyor system. The conveyor belt moves the packets along the production line. It uses a brushless DC motor for smooth and accurate movement, making sure the packets stop at the right place and move at the right speed. Fourth, sealing clamp. The sealing clamp presses and hits the packet to seal it. It stays clamped for 5 seconds to melt and fuse the packet opening. The unclamp after sealing. This makes sure the packet is closed tightly to prevent any leaks. These components work together to make sure every cat food packet is sealed properly, safely, and efficiently. Next, let me explain the key components and sensor in the quality control system used to ensure the safety and quality of the food products. First, detection head. This part houses the coil and has an opening for food product to pass through. It built to be durable, resisting moisture, dust, and temperature changes, ensuring long-term performance. Second, search coil. This is the main sensor. It creates an electromagnetic field and detects any metal object that interrupt the field as food product pass through. Third, control unit. The control unit processes signal from the search coil to detect metal particles. It manages the metal detector performance, ensuring precise detection of contaminants and efficient system operation. Fourth, user interface. The user interface includes a display panel and a control button that allow the operator to adjust the setting, monitoring system, and make any necessary changes to ensure optimal operation. Fifth, conveyor system. The conveyor moves the food products through the detection area where the search coil is located, ensuring each product is inspected for contaminants. Six, pneumatic pusher. When the metal detector finds metal contaminants, the pneumatic pusher activates to remove the affected product from the line, ensuring only clean and safe product continue through production. Now, let's go over the components used in the label stamping system, which ensures that the right labels are stamped on the package. First, capacitive proximity sensor. The sensor detects when the cat food package, which have already passed through the quality control system, arrive at the stamping point. It is positioned beside the conveyor right before the vertical pneumatic actuator. Second, pneumatic cylinder. The pneumatic cylinder is positioned vertically and provide the force needed to stamp the label on the package. It ensures the label is applied correctly and securely. Together, this component work to apply accurate label to the package, ensuring proper identification after quality control. Lastly, let's take a look at the key components used in the flavor sorting system, which sorts cat food packages based on color. First, pneumatic pusher. The pneumatic pusher is responsible for transferring the blue and red cat food package to another conveyor belt. It works using air pressure. When a sensor sends a signal, the cylinder extends to push the package and retracts with the help of a spring. Second, DC compressor. The DC compressor converts energy into pressurized air. It increases the pressure inside the tank, and once the tank is full, it shuts off. When needed, the stored air is used to power different components in the system like the pneumatic pusher. And third, connecting pipes. These pipes are essential for linking all the components that use compressed air, ensuring that the pneumatic pusher and compressor work together smoothly. Fourth, photoelectric sensor. The photoelectric sensor detects the color of the cat food packages, green, blue, and red. It works by emitting light and detecting any changes in the light as the packages pass by. This helps identify the color based on the package color. Fifth, conveyor system. The conveyor system moves the package along the production line. It is powered by a motor, typically a brushless DC motor or a gear motor, providing reliable speed, energy efficiency, and saving space. Together, these components sort the cat food packages based on their color, ensuring that each package is correctly directed according to its flavor.
Next, this is the ladder diagram for our food sealing system. First, we turn on the start button, and as you can see here, the conveyor belt motor will be turned on as well. But even after we turn off the start button, the conveyor belt motor will still be turned on due to the latching system here. Once the conveyor belt motor is turned on, the conveyor belt will start to move, and it will move the packets to the sealing station. And once the packet arrives at the sealing station, the packet arrive sensor will detect it and it will be turned on. And this will also turn on the clamp. So once the packets is clamped properly, the clamp position sensor will turn on and heat will be applied to the packets for 5 seconds. And after 5 seconds, the heat will be automatically turned off due to the heating timer that I preset earlier. Okay, I will show you the demonstration. Okay, as you can see here, the heat will be applied. Okay, and then after 5 seconds, the heat will be turned off. Okay, simultaneously, the clamp will unclamp the packets and IR1 will be turned on, which will allow the conveyor belt motor to be turned on again and move the packets to the next station. This is due to the latching system here. The conveyor belt operates continuously from the sealing process, assuming that the rejection pusher is in a retracted state. When the search coils detect any metal in the packages, the rejection pusher will extend and a 2-second timer will be activated. After 2 seconds, the pneumatic pusher will retract back to its original position. The rejected item will be pushed to the scrap section while the passed packages advance to the next stage. Once the passed package arrives at the labeling area, the passed package sensor will turn on and the stamping cylinder will be extended. The stamping cylinder will extend for 2 seconds and the passed label will be stamped by the work of the actuation pneumatic system. Once 2 seconds is reached, the cylinder will return back to its original position. Next, the packages will go through the flavor sorting system. The flavor are sorted by their packages color, which are blue, red, and green. So the conveyor belt motor is turned on by default, and when the blue sensor detect any blue packages, it will turn on. And then as you can see here, the blue cylinder will extend and push the packages, the blue packages, to other conveyor belt. So after it extends, it will quickly retract back until the blue sensor is turned off. So next, if red packages is detected, the red sensor will turn on, and as you can see here, the red cylinder will also extract and quickly retracted. until it is turned off. So for the green sensor, it does not utilize other conveyor belt. We just go straight using the main conveyor belt. So to stop this system, just simply press the stop button.
Today, I will be presenting an overview of a PLC-based quality control and packaging system for a cat food production. The system is designed to ensure efficiency, consistency, and safety throughout the manufacturing process. The system consists of four main stages: sealing process, quality check process, labeling process, and sorting process. Now, let's go through each stage in detail. Stage 1. Sealing process. The process ensures that the packaging is airtight to preserve the freshness and quality of the cat food. This process follows this step. First, initiation. When the start button is pressed, the conveyor belt moves the package towards the sealing area. Second, detection and clamping. A sensor detects the package arrival and triggers the sealing clamper to hold it properly. Heating activation. Once the clamp is in place, another sensor confirms its position and activates a 3-second heating timer to prepare for sealing. Sealing phase. Heat is applied to seal the top section of the package. After 3 seconds, the heating element is automatically off. Next, unclamping and transition. The clamper releases the package and sensor restart the conveyor belt, moving the sealed package forward. Reset and continuation. The sensor reset and the system gets ready for the next package. And the last step is cycle repetition. This process repeats continuously to ensure smooth and efficient sealing operation. Stage 2. Quality check process. The quality check process ensures that no contaminated or defective product reach the market. This is crucial in preventing health risks such as physical injuries and other health issues in cats. The process follows this step. First, continuous operation and detection. The conveyor belt moves the sealed package while a metal detector scans for any unwanted metal content. Metal detection and rejection. If metal is detected, the system activates a rejection pusher to separate contaminated package. Time rejection. A 2-second timer ensures that the package remains in place before it is pushed aside. Package rejection and forward movement. After 2 seconds, the rejection pusher moves the package to the scrap area, while the metal-free packages continue forward to the labeling process. Now that we have ensured product quality, we move on the labeling stage. I will cover the next two steps in the next slide. In this slide, I will explain about the stage 3 and stage 4. Stage 3, labeling process. In this stage, only packages that pass the quality check receive a pass label. This helps in traceability for audit and quality control. The first step is detection and activation. A sensor detects a metal-free package and activates the stamping cylinder to prepare for labeling. Time labeling. The cylinder holds the package in place for 2 seconds while the label is applied. Completion and retraction. The cylinder retracts and the package now labeled as pass continue moving on the conveyor belt. Now that we have properly labeled the package, they enter the sorting process or stage 4. Sorting process. This helps manage inventory and streamline supply chain logistics by categorizing packages based on different flavor or packaging colors. The sorting sequence is as follows. First, continuous operation. The conveyor belt moves the package into the sorting area. Sorting by color. The system sorts packages based on preset colors: blue, red, and green. Blue packages. A photoelectric sensor detects a blue package and starts 1 second timer. After 1 second, pneumatic pusher 1 is activated to redirect the package to the blue sorting pass. Red packages. A sensor detects a red package and starts 2 second timer. After 2 seconds, pneumatic pusher 2 redirect the package to the red sorting pass. And last one is green packages. No timer is required.
green package just move straight forward without redirection. So, to summarize, this PLC-based quality control and packaging system ensure a highly efficient, automated, and reliable production process. The sealing process ensures freshness. The quality check process removes defective packages, while the labeling process ensures traceability. The sorting process improves inventory management. With these 4 automated stages, we ensure quality, efficiency, and safety in cat food packaging. I think that's all for my part. Thank you.
To conclude, the PLC system in our project successfully automates several key processes in food production, which is the first one is sealing. This helps to preserve the freshness of the food and extends its shelf life. Next, quality check. A metal detector is used to identify and reject any contaminated package to ensure safety. Next is labeling. So a pass label is applied for traceability, so only safe product move forward. Next is sorting. Using a photoelectric sensor, package are sorted into blue, red, and green color based on the flavor. So these automated steps help maintain high product standard and a smooth workflow throughout the production line. So now, for our recommendation for the system is, the first one is we suggest regular maintenance of sensor, actuator, and system as a whole to keep everything running smoothly. Next, we need to have a proper error handling procedure should be implemented to manage jam, fault, or other disruption in the system. Lastly, continuous improvement is very important. We recommend regular reviewing and optimizing the automation step to boost productivity and reduce waste. Also, operators should receive staff training to ensure they are capable of handling the system and performing any necessary troubleshooting. Lastly, we recommend integrating the PLC system with ERP software to streamline data flow and enhance the production planning. So by applying this improvement, the system can reach even higher level of efficiency, consistency, and safety. I think that is all from us. Thank you.